We're at T minus 15 seconds. 8, 7, 6, 5, 4, 3, 2, 0. And liftoff of the Atlas V, launching the first interplanetary mission from the West Coast, and NASA's InSight, the first outer space robotic explorer to study the interior of Mars.
Controls, good. Check pressures and RPMs. Expect the band at this point. RD 180 continues to look good at this point in the mission. Check pressures, pump speeds.
Our newest mission to Mars is on its way. Vice President Pence visits our Jet Propulsion Laboratory, and observing our planet's ever-changing water cycle. A few of the stories to tell you about this week at NASA.
Liftoff of the Atlas V.
Our InSight mission to Mars launched May 5th from California's Vandenberg Air Force Base. Set to land on Mars in November, InSight will be the first mission ever to probe deep beneath the surface of Mars to learn more about how all rocky planets and cosmic bodies, including Earth and its moon, first formed. Also making the trip is a first-of-its-kind deep space technology experiment that will use a pair of CubeSats to test new communications and navigation capabilities for future missions, and may even aid communications for the InSight mission. Following the launch, our new administrator Jim Bridenstine called to congratulate the InSight team for a job well done.
This is a big day. We're going back to Mars. We did it from the West Coast, which is a first ever. This is an extraordinary mission with a whole host of firsts. It's important for our country. It's also important for the world, and it really establishes American leadership in a lot of ways.
Vice President Mike Pence and his family got a first-hand look at InSight's former home on Earth, our Jet Propulsion Laboratory in Pasadena, California, during a tour on April 28th. During a stop at the center's mission control, the Vice President's daughter, Charlotte, sent a command to the Mars Curiosity rover 80 million miles away. Other tour stops included JPL's Mars Yard and a building where hardware for the next Mars rover, Mars 2020, is coming together. The Gravity Recovery and Climate Experiment Follow-On, or GRACE-FO mission, is gearing up for a launch May 19th from California's Vandenberg Air Force Base. The mission's pair of new spacecraft will observe our planet's ever-changing water cycle, ice sheets, and crust, continuing the work of the first GRACE mission, which ended 15 years of operations in 2017. On May 2nd, we announced the successful demonstration of a new nuclear reactor power system designed for space. The prototype for the kilopower reactor using Stirling technology experiment converts heat from a reactor core into electricity and could potentially produce enough electrical power to enable long-duration crewed missions to the Moon, Mars, and destinations beyond. The experiment was conducted in collaboration with the Department of Energy from November 2017 through March 2018. Our Galileo mission ended in 2003. But newly resurrected data from the mission's first flyby of Jupiter's moon Ganymede show that plasma rain impacts the moon's icy surface, and strong flows of plasma are pushed between Jupiter and Ganymede due to an explosive magnetic event occurring between the two bodies' magnetic environments. Scientists think these observations could be key to unlocking the secrets of Ganymede, such as why auroras on the moon are so bright. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
The basic idea of InSight is to map out the deep structure of Mars. We know a lot about the surface of Mars, we know a lot about its atmosphere, and even about its ionosphere, but we don't know very much about what goes on a mile below the surface, much less 2,000 miles below the surface down to the center. And this will be the first mission that's going to Mars specifically to investigate the deep inside of Mars.
We know that the Earth is habitable, we know that Mars is not. There might be something that we find out in terms of the structure of Mars versus the structure of Earth that maybe can help us understand why that is.
InSight carries a seismometer which measures the seismic waves that have traveled through Mars from Mars quakes and maps out the deep interior structure of Mars.
We're going to also have a heat flow and physical properties probe which will penetrate into the Mars surface about 5 meters or 16 feet to take the temperature of Mars.
And it has a radio science experiment which uses the radio on the spacecraft to measure small variations in the wobble of Mars's pole to understand more about the structure and composition of the core.
InSight will be the first mission to pick instruments up off the deck of the lander and place them on the surface of Mars. I like to say that we're playing the claw game on Mars with no joystick. The seismometer needs to be installed in one place and basically not move in order to get the best seismic data.
We also have a wind and thermal shield that will then be placed on top of that seismometer to protect it further from the environment.
For the heat flow probe, HP cubed, it also needs to sit in one place, take a while to hammer itself down into the ground and acquire the thermal measurements over a long period of time.
InSight is a mission to Mars, but it's much, much more than a Mars mission. In some sense, it's like a time machine. It's measuring the structure of Mars that was put in place 4.5 billion years ago, so we can go back and understand the processes that formed Mars just shortly after it was accreted from the solar nebula. By studying Mars, we'll be able to learn more about Earth, Venus, Mercury, even the Moon, even exoplanets around other stars.